Hello. Okay, so before we can get into elasticity with calculus, I need to teach you one thing about a calculus tool that you may not have seen before, and that's called a partial derivative. Oh, where's my mouse? There it is. Okay, so the first thing I need you to know is I need you to look at what that symbol means. This swirly D right here, swirly D, that is the symbol for a partial derivative. But don't worry, partial derivatives are actually quite easy, and I know that you can do this. So what is a partial derivative? All partial derivative means is that you treat all other variables in the equation like they're a constant. So if I were to ask you to take the partial derivative of a function with respect to x, and that function also had a y in it, you just treat the y like it's a number. So let's do some examples. That's the easiest way to see this. So back to basics. This is something you have all seen before, I am sure. So f of x is only a function of x, and it is 3x squared. And if I were to ask you, what's the derivative of that function? One way to write that down is with this this little apostrophe. That's one way to say, what's the derivative of this function? Another way to say it, though, is with those swirly D's, and to say, what is the partial derivative of f with respect to x? Okay? And of course, you know the derivative there is just 6x. So you bring the 2 down, you multiply it by the 3, you subtract 1 on the exponent, no problem. Okay, so that one we know. Now, what if instead we had f of x and y, right? f of x and y. Well, and then I asked you, please take the partial derivative of this function with respect to x. Well, it turns out all you have to do is treat that y like it's a number. So I'm going to group it together with the 3 because the 3 is just a number and y is just some number. I don't know what it is. Maybe it's 0, maybe it's a million, maybe it's negative. I don't know, but it's just a number. And so when I take the derivative with respect to x, I treat it just like I would treat any other number. Yeah, so you just treat it like it's a number. And so then I take the derivative, I just do the same thing. You bring the 2 exponent down, multiply it by the 3, you subtract 1, and look, there's a partial derivative with respect to x. Let's try another one. Okay, so again, basic calculus, you've all seen this before. Suppose I said take the derivative of this function with respect to x. And remember, this expression here, where f prime, and this expression here both mean the same thing. All it means is take the derivative with respect to x. Okay, so you know how to do this. That plus 2 is just a constant. And so when you're taking the derivative, you ignore it. The derivative of a constant is 0, right? And so again, that derivative is equal to 6x. All right, now let's try it with a y in there. So now we have an expression f of x and y, 3x squared plus y. And I don't know what y is. Maybe it's 7, maybe it's 17, but it's just a number. So when I ask you, please take the derivative with respect to x, you just treat the y like it's a number. Okay? And so that derivative then is again 6x. All right, last example. Suppose that I have f of x is equal to 2 times x to the a, and I want to know what that derivative is. All right, basic calculus, not so hard. I bring the a down with the 2, and I subtract 1 from a. Okay, we've seen that all before. And see, I knew that there was going to be a mistake in my slides. Let's see, can we fix it on the fly? Yeah. Ooh. Shoot. Okay, so this expression here, f of x and y. Now again, I want you to take the derivative with respect to x. And with respect to x, we just treat this y here, this y to the b, it's just a number. It's just a constant, right? So I take my derivative just like it's just any old number. Oh man, I'm getting everything all messed up. Okay. Treat it just like it's a number, group it together with the other number, and you're off to the races. Okay? So that's all I had to say about partial differentiation. There are some more practice problems for you. And now on to elasticity.